Assalamualaikum everyone. My name is Nisari and today's my presentation topic is Fourier transform infrared spectrophotometer. So we discussed about today about it. So let's get started. First of all, here are contents. Number one is introduction, theory of FTIR, instrumentation of FTIR, advantages, disadvantages, applications. First of all, we discuss about the introduction. What is FTIR? Infrared spectrum is an important record which gives sufficient information about the functional groups of a compound. The region from 0.8 to 2.5 is called near IR, from 2.5 to 15 is called mid IR or ordinary IR, and that from 15 to 200 is called far IR. FTR stands for Fourier transform infrared spectrophotometer, the preferred method of infrared spectroscopy, a method for measuring all the infrared frequencies simultaneously rather than individually as with dispersive instruments. FTR spectroscopy is preferred over dispersive method of IR spectral analysis for several reasons. It is a non-destructive technique. It provides a precise measurement method which requires no external calibration. It increase scan speed, collecting a scan every second. It is mechanically simple with only one moving part. Next, we discuss theory of FTIR, which is Fourier transform infrared spectrophotometry was developed in order to overcome the limitations encountered with dispersive instruments. The main difficulty was the slow scanning process. A method for measuring all of the infrared frequencies simultaneously rather than individual was needed. A solution was developed which employed a very simple optical device called an interferometer. The interferometer produces a unique type of signal which has all of the infrared frequencies encoded into it. Most interferometers employ a beam splitter which takes the incoming infrared beam and divides it into two optical beams. One beam reflects off a flat mirror which is fixed in place. The other beam reflects off a flat mirror which is on a mechanism which allows this mirror to move a very short distance, typically a few millimeters, away from the beam splitter. The two beams reflect off their respective mirrors and are decombined when they meet back at the beam splitter, because the path that one beam travels is a fixed length and the other is constantly changing as its mirror moves. A signal which exists in the interferometer is the result of these two beams interfering with each other. The resulting signal is called an interferogram, which has the unique property that every data point a function of the moving mirror position, which makes up the signal has information about every infrared frequency which comes from the source. Because the analyst requires a frequency spectrum or plot of the intensity at each individual frequency in order to make an identification, the measured interferogram signal cannot be interpreted directly. Hence, Fourier transformation is performed by the computer, which then presents the user with the desired spectral information for analysis. Next, we start about spectrometer components. Three basic components of FT system are radiation source, number two interferometer, and number three is detector. Radiation sources incandescent lamp, non-glowed global source, high pressure mercury arc. Interferometer. The heart of the FTR is a Michelson interferometer. The monochromator is placed by an interferometer which divides the radiant beam, then recombines them in order to produce repetitive interference signals measured as a function of optical path difference. The name implies, the interferometer produces interference signals which contain IR Spectral information generated after passing through a sample consists of three active components: a moving mirror, a fixed mirror, and a beam separator. Mirrors in an FTIR are generally made of metal. The mirrors are polished on the front of surface and may be gold coated to improve corrosion resistance. Commercial FTIRs use a variety of flat and curved mirrors to move light within the spectrometer to focus the source onto the beam separator and to focus light from the sample onto the detector. Next one is the beam splitter can be constructed of materials such as SiRG deposited in a thin coating onto an IR transparent substance. The germanium or silicon is coated onto the highly polished substrate by vapor deposition. A common beam separator material for the mid-IR region is germanium, and the most common substrate for this region is caviar. Both the substrate and the coating must be optically flat. Caviar is an excellent substrate for the mid-IR region. And here is the diagram. Uh, the components of diagram is source, beam, collimators, moving mirror, beam splitter, detector, fixed mirror, detector which detects a signal. And here is the construction. The two mirrors are perpendicular to each other. The beam splitter is a semi-reflecting device and is often made by depositing with the thin film of germanium onto a flat caviar substrate. Working radiation from the broadband IR source is collimated and directed into the interferometer and impinges on the beam splitter. At the beam splitter, half of the IR beam is transmitted to the fixed mirror and the remaining half is reflected to the moving mirror. After the divided beams are reflected from the two mirrors, they are recombined at the same at the beam splitter due to changes in the relative position of the moving mirror and interference pattern is generated. The resulting beam then passes through the sample and is eventually focused on the detector. Next one is FTR spectrophotometer. After FTR spectrophotometer obtains an infrared spectra by collecting an interferogram of a sample signal using an interferometer and then performs a Fourier transform on the interferogram to obtain a spectrum. Fourier transform defines a relationship between a signal in time domain and its penetration is in frequency domain. The sampling rate is controlled by an internal independent reference modulated monochromatic beam from a helium neon laser focused on a separate detector. Here is the components which are used in a FTIR: source, interferometer, sample, detector, interferogram, decoding FT, and IR spectra. Detectors in FTR, the detectors which are used in FTR are here. The most popular detectors of FTIR spectrometer are pyroelectric detector. First one is DTGS, and then second photon sensitive semiconducting detectors, mercury, cadmium, telluride, MCT. Uh, pyroelectric materials change their electric polarization as a function of temperature. These materials may be insulators. Pyroelectric materials are semiconductors. Dielectric placed in an electrostatic field becomes polarized with the magnitude of the induced polarization depending on the dielectric constant. The induced polarization generally disappears when the field is removed. Pyroelectric materials, however, stay polarized and the polarization is temperature dependent. Next one is photon detectors. Here semiconductors are used. Semiconductors are materials that are insulators when no radiation falls on them but become conductors when radiation falls on them. Exposure to radiation causes very rapid change in their electrical resistance and therefore a very rapid response to the IR signal. The response time of a semiconductor detector is the time required to change the semiconductor from an insulator to a conductor. And here the advantages of the FTIR. FTIR instruments have distinct advantage over dispersive spectrometers. Number one is simple and mechanical design, elimination of stray light and emission contributions, powerful data station. Majority of molecules in the universe absorb mid-infrared light, making it a highly useful tool. Universal technique, sensitive, fast, and easy. relatively inexpensive and provides rich information sensitive to molecules, anything that contains chemical bonds. FTIR, I have also our disadvantages which are discussed here. Cannot detect atoms or monoatomic ions. Single atomic entities contain no chemical bonds. Cannot detect molecules comprised of two identical atoms symmetric such as N2 or O2. Aqueous solutions are very difficult to analyze. Water is a strong ion absorber. Complex mixture sample give rise to complex spectra. And here's applications of FTER: identification of organic compounds, structure determination, study of chemical reactions, study of ketoanol tautomerism, study of complex molecules, detection of impurities in a compound, conformation analysis. And here's the my presentation today. So thank you everyone. Allah Hafiz.